In this video, we're going to go over the practice sheet that reviewed simple interest, compound interest, half-life, as well as exponential growth and decay. So on this worksheet, the biggest thing was to think about what formula we needed based on the information given to us in the problem. So let's read the first one. It says, Josh deposited $250 in his bank account that pays 3% simple interest. In 1 year, how much interest will Josh earn? What will your account's balance be in 1 year? Okay. So they tell me $250 is deposited in the account with 3% simple interest. And they want to know how much interest I'll have after 1 year and what the account balance will be after 1 year. So when reading this, the key word is the simple interest, meaning I'm going to use this simple interest formula. So I'm going to use I equals P times R times T. So my principal is my starting amount, my P, so that's 250. My R is my rate or my percent, but we always turn this into a decimal. So if I have 3%, I'm going to move this decimal place 1, 2 times. That's the same as 0.03. So that's my rate. And then the time was 1 year. And so when I do that, I know after 1 year, I'll earn $7.50 in interest. So that's the interest I will earn, but then the account balance is always your principal plus your interest. The original starting amount, so $250, plus the interest I earned, which was $750. So that's going to be $257.50 will be my final account balance. Okay, question 2 says, find the amount of money accumulated if Ann puts $1,200 in an account offering 5% interest compounded annually for 5 years. So again, this keyword compounded means I'm using compound interest. So my compound interest formula is going to look like this. And then we'll talk about what goes in each spot. So A equals, well, that's the final amount, so we don't know that yet. P, again, is the principal or the starting amount, so that's $1,200. R is my rate, but again, my decimal has to be turned in, or my percent, excuse me, has to be turned into a decimal, so 0.05 over. N is the number of times it's compounded. So this says it's compounded annually, which means it's compounded 1 time per year, so my N is going to be 1. So 1 is going to go in for this N and for this N. And then 1 times 5 years. So my calculator, I'm going to enter 1,200 times 1 plus 0.05 over 1 to the 5th power. And this will get me $1,531. And then if I round correctly, and 54 cents. If you said 53 cents, that's okay, but in the calculator it says 0.537. The 7 means that 3 gets rounded up to a 4. And that would be our final answer for number 2. Number 3 says, find the amount of money in the account, find the amount of money accumulated if Mike puts $1,650 in an account offering 5.5% interest compounded quarterly for 3 years. Again, I have that word compounded, so I'm going to use this compound interest formula again. So I'm going to scroll down a little bit just so I have room to write. But I can still see my formula right here. So A is going to equal, P is the principal or the starting amount, so 1,650. 1 plus my rate, 5.5%. So 5.5%, to make that a decimal, I move it 1, 2 spots to the left. So that's going to be 0.055 over. Now the N is how many times it's compounded. So compounded quarterly. So a quarter, there's 4 quarters in a dollar, 4 quarters in a basketball game. So N is going to be 4 and 4. So 4 goes in 2 different spots. And then T is time, which was 3 years. So in my calculator, I'm going to put 1,650 times 1 plus 0.055 over 4 to the 12th power. And when I put that in my calculator, I will get $1,943.81. Question 4 says, find the amount of money that John will need to invest in a savings account. Now, if he wants the balance to be $15,000 in 8 years, the account compounds monthly with an annual rate of 6%. All right, so this is a little bit different. They want me to find the principal. That's what they want me to find, the starting amount. So we're still going to use this compound interest formula from 2 and 3. But instead of finding A, my A is actually going to be $15,000 because that's how much I want in the account at the end. So $15,000 is going to equal P times 1 plus, well, my rate is 6%, which is the same as 0.06, over, well, N is how many times it's compounded. So compounded monthly, meaning my N is 12. And 12 goes in 2 spots over 8 years. So I'm going to simplify this. $15,000 equals P. I'm going to type, well, let's simplify this first, actually. To the 12 times 8, 96th power. So I'm going to have 15,000 equals P times. Now I'm going to type this whole part in my calculator. So 1 parentheses 1 plus, I'm going to figure out what P is multiplied by. So 1 parentheses 1 plus 0.06 divided by 12 to the 96th power. And that gets me 1.61. Now, P is multiplied by 1.61. So to get the P alone, I'd have to divide both sides by 1.61. And I'll leave you with my principal for the starting amount that I want. If I want to start off or end with $15,000, it means I need to start with the account having $9,316.77. This one was a little bit tougher, so if this one was hard for you, that's okay. This is more like a challenge problem. So if this one was a little bit harder for you, that's okay. All right, question 5 is a half-life problem. So if I scroll back up at the top, that means I'm going to be using this formula. So I'm going to use that formula down here. A equals P times 0.5 to the T power. Okay, so it says the half-life for the isotope X is 2 years. If you start with 4 grams, how many grams will be left after 8 years? So remember with half-life, the first thing we always want to do is figure out how many half-lives the product's going to go through. So the total time is 8 years, and a half-life happens every 2 years. So that means the product will go through 4 half-lives. So now I know that my T is 4. So A is going to equal, well, the principal amount was the 4 grams, the starting amount. So 4 times 0.5, and then raise to the 4th power. And when I put that in my calculator, I will get that I'll have 0.25 grams of the sample left. All right, we have a few more problems on the next page. This next problem, they actually gave us a formula, so we're going to use the formula they gave us. We're going to use this guy. So it says radioactive material will decay over time. A certain radioactive material will decay according to the formula A equals 200 times 0.80 to the T power, where 200 grams is the initial amount, and each year the matter decays by 20%, which is why it's 0.8, because 80% is what remains each year. So that's a little bit tricky. That's why they gave you the formula on this one. So it says, using the formula above, find after T years how much will be left in the 200 gram sample. Well, they're telling me T is years. So that means in my formula, they give me all the numbers except I need to plug in 4 for T. And when I do that, and I type it in my calculator, I will get that 81.92 grams of the sample will be left after 4 years. Question 7. You have inherited land that you purchased for $30,000 in 1960. The land value increased by approximately 5% per year. What is the approximate value of the house in 2011? Or land, sorry. So we're talking about increasing here. So that means I'm going to use exponential growth. So I'm going to be using this formula. So I know that my A, or my initial amount, is 30,000. I know that my rate is 5%, but written as a decimal, that's 0.05. And then I need to know what my X, or sometimes it's called my T, is, this guy. Well, I started in 1960, and now they want to know in 2011. So I need to figure out how much time has gone by. So I'm going to do 2011 minus 1960. And that means 51 years went by. So my T, or my X, is going to be 51. Now that I found all those parts, I'm going to plug them into my formula. So 30,000 times 1 plus 0.05 to the 51st power. So that means after 51 years, I'm going to type this in my calculator, and it'll tell me how much the house is worth. So it'll be worth $361,223.09. All right, last question. An adult takes 400 milligrams of ibuprofen. Each hour, the amount of ibuprofen in the person's system decreases at a set rate. After 5 hours, there's only 72 grams. Actually, we're going to skip this question, so don't worry about question 8. I will delete it off your worksheet so you won't even see it. If you have any more questions, let me or Mr. Theriault know.